GGDisASM takes a binary opcode and converts it into its corresponding assembly instruction. This helps users understand what specific operations are being performed at a given memory address. Depending on the architecture of the target application, this function can disassemble instructions for both 32-bit and 64-bit architectures. The first line of code defines a variable called address and assigns it to a value. The value represents a specific location in the memory of the device or application. Memory addresses are usually given in hexadecimal format, starting with 0x. In the context of GameGuardian, this address is where the machine code or binary data you want to examine is stored. The next line defines another variable called ASM type and assigns it the value GGASM-ARM. The variable ASM type specifies the type of assembly language that will be used for disassembly. Assembly languages are low-level languages that are closer to machine code, and different processors have different assembly languages. GGASM-ARM tells GameGuardian that the disassembly should be done using the ARM architecture. It is a widely used architecture in mobile devices and embedded systems. By specifying GGASM-ARM, you are telling the script to interpret the machine code at the given address as ARM assembly instructions. GGGetValues function retrieves data from memory at specified addresses. You use this function when you want to read what data is stored at a particular memory location in a program. The result variable will store the retrieved data. After the function call, result will hold the value that were read from memory. Address assigned to address. The first address is a key in a table. This key tells the function what specific piece of information you are providing, in this case, the memory address where you want to read data. The second address is the variable you defined earlier in your script. This variable holds the actual memory address you want to access. The flags key specifies the type of data you are expecting to retrieve from the memory address. In this case, GG-type dword indicates that the data type at this memory location is a dword, which is a 32-bit integer. The opcode variable stores the raw binary data retrieved from memory. This binary data is called an opcode and represents a specific instruction that the CPU can execute. The result variable is a table that holds the values retrieved from memory. When you access result with index 1, value, you are getting the first value from this table. This value is the binary data, or opcode, that was stored at the memory address you specified earlier. %exit is a placeholder used to insert a memory address into the formatted string, and it formats the address as a hexadecimal number. %exit is a placeholder used to insert a string into the formatted string. In this case, it will display the disassembled instruction. The address variable holds the memory address from which the original binary data, or opcode, was read. It is placed in the %x placeholder in the formatted string. ASM instruction variable holds the disassembled instruction in a human-readable format. It is placed in the %s placeholder in the formatted string.